Here is homework number 13, lucky number 13, and we have this metal plate suspended by 3 cables in the U-Hart machine shop. It weighs 575 pounds and acting at the center of the plate. And there's a force of 225 pounds acting right there. It's applied at point D, and the dimensions are 3.5 feet, 2.5 feet, 2.5 feet. We want to determine the tensions in all of the cables. And we want a correctly labeled FBD as part of this. So let's move you over to here. Boom. And let's move this right here. Okay. So we have page 1, Dr. Deal. I'll put my name up there. You should put your name. And this is ES110, and this is homework 13. Problem 1. And look at all this, all those eraser shavings. I must make a lot of mistakes if I have all those eraser shavings going on there. Alright, let's see. I'll draw this plate. I'll draw a plate. Something like that. Boom, boom, boom. No cable in the bottom corner there, but we get here's our axes. And draw them all in there, and here's Y, and here's X, and here is Z off the edge of the paper there. And let's see, I guess I'll make it look like a plate. Give it some thickness. Boom. And it's being suspended by these cables right up to there. Loop-de-loop. This is B, to there, boop, C, and A, okay, and here's point D, there's a force right there, FD, and in terms of dimensions, we have something like that, something like that. All right, like that. Put a little flare in those arrows today, huh? An X, B, C. And this is ZCD right there, and then this is ZAD. All right, and the given. But this takes up a lot of the video time, doesn't it? You probably would want to skip right through this part of the thing. But I'm torturing you. Well, that's not really why I'm doing it, but here. I'm trying to get you to do the same things I'm doing. I could just start taking points off for your lack of professionalism when you're putting stuff in there. I'll just keep trying to set a good role model, be a role model. See, XBC is going to be 3.5 feet. See, I used to do it, ask people to do things, and then I wouldn't do them myself. And I find that's just wrong, right? So I'm trying to set a good example. Find the tensions in the ropes. Okay, so this is a three-dimensional one, so the FBD is really not all that much different from what I just drew, right? But trying to set a good role model, trying to get you doing good practices, doing good practice, because you're going to be going on to other professors here, and I want you to demonstrate that the professor you had for your statics class sets you on the right course. that you're going to be doing all the right things. So I'm going to call this FB, FA, FC, and of course we knew this was going to be FD, and then maybe I will just try to kind of sort of find the center of this right there. Dot, 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 dot. There you go. There's the weight. Put the weight onto there. And maybe some dimensions. Ooh, I don't know. They said the weight was actually going to be 575 pounds. And FD was equal to 225 pounds. And maybe I could even put in this dimension here to the center of this thing here. I said this is 3.5 feet, and that's fine. 3.5 feet, but each of these is going to be 1.75. I just did that in my head, so I don't know if I can trust it. 1.75. We know this dimension, that dimension's going to get in the way. All right. I'll put them in there small. 2.5 feet to there, 2.5 feet. There you go. All right, so what we want to do is we want to take the sum of the moments. Boom, boom, boom. All right. Let's. So we're going to say the sum of the moments about. We can say the sum of the forces too. Let's do the sum of the forces first, right? That's going to give us 3 equations. It's really just going to give us 2 equations as everything happens. So we're just going to give us 1 equation, right? Sum of the forces is equal to 0 right here, and everything is in the y direction. So we could say sum of the forces in the y direction, couldn't we? So we would just say that FB plus, why wouldn't we start with A? Alphabetical order, right? FA plus FB plus FC minus 225 minus 575 equals 0. And that's all in the J direction, right? So I can't do that math in my head. 225 and 575, and we're at 800. Okay, so we really just said that FA plus FB plus FC was equal to 800 pounds, right? And so that's our first equation. We have 1 equation and 3 unknowns. Let's go to the sum of the moments. Now, one thing that we know is the sum of the moments we need to do about a particular point. Let us do it. Oh, I don't know. Let's do it about C. That just looks like a good candidate to me, right? So we're going to do it about C. So we know that we're going to have to take the sum of the moments as vectors, and so that's going to be each of these forces right here crossed with its position vector, right? Fortunately, it's not going to be too difficult to do in as part of this, right? There's going to be a lot of zeros, but there's a lot of work involved in this, right? So this is going to give us enough equations, I believe. I think so. We're taking it on faith, right? So first, let me write out all these vectors right here. FB is going to be equal to, and I guess I'll make all these vectors, right? FB, you know, we know that they're all what they all are, right? It's just going to be FBJ, and then FA. I should have done FA first. Equals FAJ, and then FC. It's going to be FCJ, and then FD is negative 225J, and these are pounds, and W is negative 575J pound, right? Now we're going to need the position vector for each one of these right here, right? So R B with respect to C is going to be everything in the negative. It's going to go to B from C, and it's in the negative X direction. So it's a negative 3.5 feet. Well, not feet, I, and then feet, right? And then R, let's go for A next. RA with respect to C is going to be equal to, that's negative Z, negative 5, and we'll call it K, feet. R D with respect to C is going to be negative. We're also going to go in the negative there. It's going to be a negative 2.5 K feet, and then R. Well, I guess we'll say W. Where W with respect to C is going to be, okay, so it's going to be negative that way and negative that way. So it's going to be a negative 3.5 I plus a negative 1.75 K feet. All right. So there's going to be a whole lot of paper. It's going to take a whole lot of time. How much time we already take? It already seems like it takes a long time. We're already taking 12 minutes, so it's going to be a long problem. So you might want to fast forward through some of this so you can see what you have to do. But this is being an engineer. Just sticking it up. Taking care of business. All right. So some of the moments about C. I already wrote that. We're going to say, let's go one at a time. Let's go to FA. No, dummy. It's the distance. It's this guy. R A with respect to C crossed with FA plus R B. Let's go B. B with respect to C cross FB plus C is where we're taking it from. Let's go FD. R D with respect to C cross with FD plus W. No, R. Go to position vector first. R W with respect to C crossed with W equals 0. And they make this look so quick in textbooks, I tell you what. All right. So let's put these on here. There's going to be 4 of these, I, J, and K. We're going to use a lot of paper. Okay, so RA with respect to C, we just put that in there. It's going to be 0, 0, and then negative 5. Right, and then FA right here is just going to J. 0, FA, 0. Plus B with respect to C. So, and that's in the completely in the I. So we got I, J, K. So we got a negative 3.5, 0, 0, and that's crossed with B, which is also J. Plus D, right here, right? And we have I, J, K, and let's see, where we're going to go with him. I, J, and K, and where did you go? I lost my place. D. D, D, D. Where's D? D is negative 2.5 K. 0, 0, negative 2.5 right? And then D is, we have that. It's 0, negative 2, 25, and 0. And then the last one we're going to have is, I'll put them down here. I, J, and K. And you are going to be, where'd you go? The W, right? So he's got two parts to it. He's got negative 3.5, 0, and negative 1.75, and 0, negative 575, and 0 equals 0. So we've got ourselves a whole lot of determinants to do, but we should be pretty good at them by now. We've done a lot of them. I'm going to take a poll to see if anybody watches these damn videos, because it takes up a lot of my time. But I don't bother re-recording them, so that's all right. I guess it's not that bad. All right, let's find the determinant here. All right, so we start off. Let's start off with I. We go, okay, yeah, we got some. All right, but it's going to be 0 minus 5 FA. All right, I. Okay, what about J? Nope. 0, 0. What about K? Nope. 0, 0. So it was only at a moment about I, right? For that one. And let's go to this gun right here. Okay. So we're probably going to get kind of lucky here. Okay, you got I. Nope. No good. J. No good. But K. We got one about K, right? So we're going to take this and say, okay, when we're K, it's just going to be the negative 3.5 FB. All right, and then minus 0, right? So that's just going to be K. Great. And then this guy right here, okay, let's take it for I. Oh, we got something for I. All right, so when it's I, that times that, minus that, times that, right? So we're going to have a 0 minus, but here we're going to minus 2.5 and a minus 225. All right, that's interesting. And that's going to be times I, right? Got anything times J? No, it's going to be zeros. Okay. Anything in K? No, zeros. We're golden. Last one is going to be for the weight. Oh, come on. There you go. So for the weight, I guess we're coming down to the next thing down here. Let's go plus. In the I direction, yeah, we have something. All right, we have 0, and we have minus a minus 1.75, and that's times a minus 575. Right, and that is an I. Right, but then we also have a for the J right here, let's see, it would be that cross that, and that cross there. Okay, no J. And now for the K, we're going to have that times that, and that times that. Okay, so we're going to have a negative 3.5 and a negative 575, and then there's a 0, right? So we don't care, right? So just double checking that, and that. Yep, okay. And this is the K. All right, so what we have here is these are two equations. There's two more equations that we're left with right here. So gather the i's, right? So we gather the i's here, and we have a 5 FA, and okay, so it's negative, negative, negative. We're going to have a minus, so that's going to be 2.5 times 225. Let me calculate what that is. Right. So this was minus, minus, minus. So it ended up being minus. So we have a 2.5 and a 225, and times each other, and we get a 562.5. Is that right? I think so. Doesn't seem right. 2.5 and 225. Yep, that's what I got. Okay. And then any other I's? Oh, yeah. We got an I right here. Sure. So that's going to be minus. Okay. So minus 1.75 times 575. Boom. And so we get a 1006 equals 0. So FA, we're able to find out, is going to be those two things added together, 1,569 pounds. Woohoo! We got one of the answers. All right, let's take a look at K here. In K, how did we do K? We got a negative 3.5 FB. All right, so that's a little concerning. It's negative right there. This was good. This was positive right here. But let's see. That's the other things. Well, I hope these are going to be positive here. So this could be work out. We only got this guy, 3.5 times 575, and it's negative. Good. So he's positive. That's good news. 3.5 and 575 times, and I get 2,013 equals 0. So I'm able to get FB divided by 3.5. I just messed this up above. Why didn't you stop me? I just forgot to divide. Okay, so I divided that right there. So I got, okay. Oh, this is interesting. I just got 575. 2013 divided by 3.5, and I get 575. What did I do wrong? What did I do wrong? Up above. I'm looking at this right here. And that's about the Z. And I don't see it. I did something wrong. I don't think that should equal 575. I don't think FB should equal 575. I don't believe that. I don't believe that for a second. There's got to be some mistake in here. Let me pause and I will look for my mistake. Found it. All right, so in the position vector that I was supposed to have for this one right here, that was supposed to be a 2.5. Thank goodness. But that's what you got to do as an engineer, man. You got to try to find your mistakes. Be on the lookout. There's a lot of fun work too as an engineer. There's just some things. In order to do the fun stuff, you got to do the kind of tedious stuff. But it works out. It does work out. Trust me. It is fun. There is a fun aspect to being an engineer. It's hard to appreciate that right now. I got you. All right, so this is where that shows up. This is the only place that shows up. So that's going to change this answer right here. This is still going to be 3.5 because that 3.5 came from right up here, right? So we have 2.5 and 575. That makes sense. 1,438. And we divide that by 3.5 here, and I get 410.7 pounds. This guy up here, I forgot to divide 1,568.5. Is that right? Do the numbers right there? I think so. And divide it by 5. 313.7 pounds. And then the last one, we can come back to this equation right up here, right? They all have to equal. So from equation 1, we had FA. We know FA, 313.7. We know FB? We sure do. 410.7. We don't know FC, because that's the one we decided to take it about. But we do know that this has to equal 800 pounds, right? So we can find that FC, and ooh, well, look at that. FC doesn't do a lot, does it? 800. That's interesting. That makes me suspicious. Makes me suspicious of how smaller he is than all the other ones right in there. So I might actually want to test it out. I might want to test this out. I don't quite trust this. But I'm very, very tired. So I might just go take and find a similar problem and just double check that the corner of this right here doesn't have as much tension as that one and that one. That strikes me as a little strange. Well, I guess maybe, okay. So what we're dealing with right here is that, let's just imagine that this cable wasn't there, right? This thing could potentially flip over, but if there was just a force in the center, it would balance between these two. Now add a cable right in there, and then add this force right here. Well, most of this force, I don't know. I still think I must have messed up somewhere in here. You know, I must have messed up somewhere in here. That's my thought. It's probably in the position vectors. It looks right. Well, anyway, we will just do our best and see. We'll live to fight another day.